provide a brief introduction to our company. The title of my talk is called Space, Climate, and Beyond, Unleashing Technology for a Sustainable Future, and it's going to really concentrate on the second word and the last word, climate and sustainability, which is the area that I have the most expertise and oversee the programs within the company. But first, a lot of us may not know about Leidos, so I'll give you a quick placement on that. Leidos is a Fortune 500 company based in the DC area. We are one of the largest federal contractors in the United States, and these are some of our key major customers. I'll talk about NASA, given all the interest that we have in this meeting about space. 46,000 employees. A lot of them are cleared with secret and top secret. And we're a space and technology leader, so we have a lot of PhDs that are focusing on very tough problems across many different areas. The three main sectors that we have, and sorry, yeah, I skipped the, we've got sectors. We recently reorganized the company into sectors, and effective in 2024, I will be moving to the health and civil sector, and I'll be but we also have digital modernization, defense, and the focus largely is in defense, and that includes both space and as well as IT. So these are all, I'm going to concentrate on our NASA portfolio. We've been working in NASA for over 50 years from our legacy SAIC program. Within our integrated mission operation, we are the prime contractor that provides cargo to the International Space Station. So we send all the cargo and do all the logistics underpinning that. We are also heavily involved in operating all the health and human performance activities, and we're doing a little bit of science at other NASA field centers. And so on the defense side, we are building parts of the Artemis program, including the Universal Stage Adapter. This is a little old. We actually bidded the human landing system that was won by Orbital, by Jeff Bezos' company, because he's a billionaire. He gets to decide which contracts he wants to win. And then we also build the Orion laser air monitoring system with JPL. On the IT side, we basically are the top IT supporter for the entire agency. We own the largest prime contracts for enterprise mission support, everything from laptops to cell phones to servers, and the entire enterprise, including security for that system. And so we're, as it pertains to this meeting, cargo mission and health and human performance are some of our core strengths. Our new vice president used to be part of the ISS National Laboratory. Deborah Wells, she's someone who's well known and on those circles. And, while I'm the chief scientist for civil, my work is mostly focused on the science piece. But this is really the operational piece that supports station and all the astronauts. I was speaking with astronaut Akaba, and he knew about us, which is very heartwarming to know that the work that we do involves a lot of the research and the priming for extended operations in space. And I think it's very important for us to, make note of the fact that the ISS is going away eventually. And so we're all, as an industry, are developing pipelines towards commercial and longer duration business models, and that means partnering with those entities that will be hosting new LEO platforms moving forward. And that part of what I'm trying to do is trying to make sure that as we're developing those business models, that science becomes a critical piece of what we do and deliver. All right, so defense. So the key thing about defense is delivering stuff quickly. So we do this for the Space Development Agency. We're part of the FASTSat program that provides end-to-end capabilities out of our offices in Huntsville. This is our subsidiary known as Dynetics, and we have the entire end-to-end system to do mission design, integration testing, shake and baking, clean rooms that are needed in order to be able to deliver projects like the SNDC Lone Star to track missile programs. All right, so and then this is the piece that I'm in charge, climate systems and looking at the entire value chain. And so both from the hardware development of space sensors to the data systems underpinning the analysis that are then used to conduct very critical understanding of the Earth as a system in support of many different civil space agencies, both on the US side and the European side, as well as Japan. So we work with all major space agencies involved in both low Earth orbiting and geostationary products. And so these are 4 of the different contracts that we have right now with NASA. And a lot of that is science team leadership, so operating missions and developing the processing streams to generate long-term climate data records from long duration missions that are used to understand climate trends. And so I'll just go very briefly from down to this. This is the work I'm conducting as the principal investigator for the Terra Aqua Modis instrument. This involves the development of climate data records and continuing those climate data records from the current Earth observing system launched in the 90s to now into NOAA's operational Joint Polar Satellite System. And so I'm part of the science team on both NOAA and NASA that oversee the continuation of these long-term series that are used by everyone, from weather forecasts to mapping fires from space to doing some very unique things that were developed with collaborators here in Puerto Rico. So let me show you some of those things. So the flagship instrument on board the JPSS program is the Visible Infrared Imaging Radiometer Suite, known as VIRS. It's built by Raytheon and is on board. There are already 3 flight units and 2 more being built right now at Ball Aerospace, being integrated on the JPSS system. This is the follow-on to MODIS, and it offers 22 different spectral channels to map the Earth twice daily, both day and night. It covers 3,300 kilometer swath, and it provides all these very critical parameters to understand Earth system change. And the one that I am the most proud of is day-night visible imagery. The VIRS instrument has a day-night band, which allows us to measure radiances down to nanometer sensitivity, 10 to the minus 9 watts per centimeter squared per steradian, and that means that you're able to detect low-light imaging patterns, both natural and anthropogenic, and that give you a very direct measure of human activities. And so I was part of the team that helped develop this instrument and operate this instrument using data products that were validated here in Puerto Rico. And so back in 2016, I led a small team with the Environmental Quality Board and the Puerto Rico Conservation Trust. And we were meeting, this is in Rio Piedras, in Jardín Botánico, and we deployed a tarp. This is the most expensive tarp I've ever built. It's a $10,000 NIST traceable tarp. And we deployed it in the lands of Pitaya in southern Puerto Rico, the only dark sky natural resource that we have, this pitch dark little region here. And we turned on a 20,000 lumen lamp and we could see us from space. And so that is how sensitive this is. That tiny little lamp, well, actually 2 of them, creating a beam speed that is well characterized over a small diffuser at Goddard Space Flight Center. This is at the radiometric calibration facility. And look at the scale. This is 1 nanowatt. So this is a 1/4 nanowatt of detection. And the VIRS instrument design was 3. So this is 10 times more sensitive than the actual intended design of the instrument. So what can you do with that? You can measure Christmas lights from space. So let me show you some pictures of, well, first of all, if you're in tourist in Puerto Rico, you have to have el plato de Navidades. Christmas lights is very big in Puerto Rico, and this is how it looks like from space. And so you can see some of these changes, and this is not just one single look. This is a data set that analyzes trends, seasonal recurring trends of lights from the non-Christmas part of the year in the summer versus the very, very longest Christmas in history, in civilization, which is Puerto Rico. It starts November 1st, and it doesn't end until San Sebastián. So there's a ton of lights in Puerto Rico during this time, and that means that the lighting actually changes dramatically. Up to 20-30% more light is consumed in Puerto Rico during this period. So that was a nice paper. We did a press release at the AGU that hit over 2 million looks in YouTube, and I actually translated that in Spanish. And then I got a grant from NASA to study sustainability of lightning from space and understand how those changes in energy can be traced to lights. And the grant started in 2017. So that's what happened in 2017. So the entire grant was canceled, and we actually, instead of measuring beautiful Christmas lights, we're measuring that. This is the town of Caguas, Puerto Rico. And if you know Caguas, Caguas is the line that connects all electricity. Comes from the south of Puerto Rico. Electricity generation is done primarily in the south, 75% of it. And it goes all the way up to the metro area through Caguas. So if Caguas doesn't have power, nobody has power. And so I was part of, at the time I was an NASA civil servant, and I was leading the interagency response to this. This was in the cover of Washington Post. And these are some results, because you can see street level changes. You can start comparing municipalities that are adjacent to each other and start looking at the differences in recovery. So you can see the lights coming back in Aguas Buenas, which is a health hotspot that, and you should read the report that came out of Arielis in the Washington Post this week. Really good report on the health impacts and the very rich town of Guaynabo where all the rich people live. So anyways, this is looking at the legacy conditions of Maria 3 years later after the earthquake, which hit the southern piece of the island. So these are the outages detected 3 years later caused by an earthquake that impacted a system-wide blackout over the island. And then this is Maria, so you can actually start looking at the morphology and intersect of these outages. And that is very important, because under more frequent disasters, the issue of legacy conditions, how a disaster here has impacts, how the disaster here 3 years later will impact, as you see more, how it changes the behavior of future disasters. And this is an area that we put a lot of thought leadership and have worked on policy changes under the framework of the National Academy of Sciences. So this is an area where we're trying to drive policy. And where we've been very successful under the current White House leadership to do some changes. So this is Fiona, and in Fiona, the disaster declaration did not include many parts of Puerto Rico, including the town of Loíza and the town of Hormigueros and the Valle Hermoso Abajo part, where they did not receive initial federal assistance. But after we showed these maps to the Director of Puerto Rican Affairs at the White House, that declaration was amended, and those guys got a $700 check. So this is important stuff. It's not operational, it's still research. But it is being done for Puerto Ricans, by Puerto Ricans. And we are working our way to try to continue developing that capacity. We have sponsorships right now with the USDA Caribbean Climate Hubs. So we're going back to Rio Piedras again for another different reason, to continue doing the work to advance sustainability in Puerto Rico in the long term. And so our core principles at Leidos, no matter what we do, whether it was sending tacos to the ISS or helping devise a new water system for astronauts, or looking at ways to build new sensors and phenomenologies, this is our North Star. And it goes around the idea that whatever solution we provide, it must try to satisfy one of these fundamental pillars on transparency, equity, and accountability. And so I was very surprised by this. It's my first time coming to a Puerto Rico Science Innovation Summit. And I'm coming back to my office saying, hey, our competitors are here in Puerto Rico. Raytheon is here. Lockheed Martin is here. Collins is here. Why aren't we here? We should open an office here. And so if you agree with that, and you can help me make a case too, so when I ever go back to Virginia, I'll be happy to talk to you about that. So thank you so much. Any questions? Yeah, so let's go back to that, because that's the problem we're trying to fix. So all these satellite platforms these are polar orbiting imagers, and so they cross the equator at the same local time every day if they maintain their orbital track, which it's dependent on fuel and the lifetime of the instrument. Unfortunately, because these are weather satellites, these are not nighttime satellites, they're weather satellites. They have all these other instruments that have other more onerous requirements, and in particular, JPSS has a requirement that's more important than lights, and that's the weather forecast. And a weather forecast is driven by understanding convection at a very particular time of the day, which is 1:30 p.m. And so if you want to measure hurricane wind speed, the best time to measure the Atlantic is at 1:30 p.m. The problem is, as the satellite crosses the equator and goes to the nighttime portion, you're at 1:30 a.m. in the morning, and everyone, except for the partiers of San Sebastián and Old San Juan, who are staying awake all morning until 3 a.m., everyone's asleep. So you're not really capturing human activity in all its dimensions. I wrote an actual commentary in Science magazine asking NOAA to move SWAMI MPP to an earlier nighttime orbit, but there's not enough fuel to do that. We would have to figure out a very new, innovative way to grab a robot, bolt it, and move it. And this is hard, but it's not impossible, and it's already being entertained for Landsat 7. And so, but the true solution should be to build an entire dedicated nighttime satellite. So I was talking to Francois that Airbus is trying to pitch that right now to the European Space Agency. So we're proposing the Europeans to, as you know, JPSS program is a joint polar program between Europe and the US. The US offers the afternoon portion, Europe offers the morning portion, and that morning portion will be delivered by the Airbus system known as METIMAG onboard the EUMETSAT next generation polar orbiter. We need more observations in this domain, and industry can play a major role in filling in those gaps to help understand processes. The other issue is, and I'm sorry I'm going too technical on this, but the channel, the sensitivity of this channel is just a single panchromatic band that starts in the green all the way to an EIR. So all the LEDs that we're seeing changes, there's very little sensitivity in us detecting that. And that's a big problem for people like economists who are relating GDP forecasts to lights, because the more lights, the more GDP. Well, guess what? If you're not capturing LEDs, that correlation no longer holds. And there's the most cited paper in nighttime remote sensing is by Bill Norhaus, Nobel Prize of Economics, 2016, Nobel Prize of Economics, who made that correlation, used by the World Bank, it no longer means anything because the city of Milan just went entire LED and it looks now like it lost 20% of the population. So I think we all make all these empirical assumptions about observations. You need to be very careful. And there's a lot of, those are problems, but also opportunities for investment and development of new missions and instruments. I think Leidos, under my leadership, will devote some investment in that domain, but we need to find some anchor customers who are willing to bite and understand how this is equally as important as running a numerical weather forecast. We're not there yet. I hope we don't have to have another Hurricane Maria for people to understand why this technology is important. Unfortunately, that's probably what's going to have to happen. It just has, climate change is $1 trillion problem that is just like a meter moving very slowly, and people are not moving fast enough.